Section 6.2 is all about solving systems of linear equations using substitution. So what is substitution? Well, that's what you're going to find out. It is another method to solve systems of equations. So this is our second method other than, the guess and check method. So, the objective or the goal here is to solve systems of equations using substitution. All right? So that's a couple, well, really just one vocab word. It's the substitution method. Um, Basically, the substitution method is a method of solving a system of equations that requires a lot of substituting. All right, and I'll give you the steps for it right now, the basic steps for using the substitution method, and then we'll show how it works with a couple examples. So first of all, you got to make sure one of your equations, because remember, a system of equations has two equations. One of them is solved for either x or y. All right, then you take that, whatever that, so like if we have y equals 5 plus 2, or 5 plus x, you plug in that 5 plus x for y in the other equation. Then you solve for the remaining variable. And finally, whenever you solve for that variable, you plug into either of the original equations to solve for the other variable. So how does that work? Well, let's see here. Here is an example of the substitution method. It says, what is the solution of the system? And it'll end up being an ordered pair. It'll have an x and a y. Use substitution. So let's use it. First step, make sure that one of the equations is solved for either x or y. And it looks like that's already done. We have that one solved for y. Step 1. Substitute the expression for the variable in the other equation. Now, picture this. Y is equal to 3x. This is what it says here. Y equals 3x. That means wherever you have y, that could also be 3x. Wherever you have 3x, you could also plug in y. So instead of y right here in the second equation, we're going to put 3x. Because it says y is equal to 3x. So why not just put in 3x there? So step 2, we're going to do x plus instead of y. This is where we're substituting. We're going to put x plus 3x equals negative 32. Okay, now this one's gone because we plugged in for the y. Okay, this is our new equation. And guess what? There's, whoops, I think I wrote this wrong. 32 there. There is only one variable. There's x plus 3x. So right now we're going to combine those two because they're alike. So we have 4x equals negative 32. Solve for x by dividing by 4. All right, we already did, oops, sorry. We did step 2, so I'm going to check that off. Now we're solving for the remaining variable, which is x. Divide by 4, x is equal to, why did I put 3x there again? And why do I keep bumping this? X is equal to negative 8. Excellent. We have the x value. So our ordered pair, we have negative 8 as our x. Now we just got to figure out the y. So we solve for that variable. Finally, plug that answer into either equation to solve for the variable. So I'm going to erase up here so we can see what our original equations were. And really, it doesn't matter which one you plug it in for. It'll work either way. So let's plug it into, let's do both actually. Let's plug it into this one. So we have y, to solve for y, we're going to do y equals 3 times x is negative 8. So y is equal to negative 24. Awesome. You can check it again. You don't have to do it this way. You can do it either way. If you did the first part right, it should work out. We'll plug in negative 8 for x plus y. So I'm plugging it in for here now. Equals negative 32. Solve for y. We add 8 to both sides. Y equals whatever negative 32 plus 8 is. It would be negative 24. You get the same thing. So basically, this is our answer. We have x is negative 8, y is negative 24. That's the ordered pair for that system. That would work. All right. I really should add a fifth step here, which would be check your solution. Okay, if you plug it in, they should work out. They should be able to, they should check out. So what I'm going to do here is actually take this. Oops. So I'm going to look at each of those equations. Y equals 3x. Plug in our two variables. So you have negative 24. Is that equal to 3 times negative 8? Negative 24 equals negative 24. So that's good. Now let's try it in the other one. Let's plug in for x is negative 8 plus a negative 24 equals negative 32. Negative 32 equals negative 32. That means you did that one right as well, and your solution works. There you go. Alright, that is the substitution method. Let's try another example. The more examples, the better. So, example 2 says, what is the solution to this system of linear equations? And, neither of them is solved for y. So we're going to have to do that. Let's pick one of them to solve for x or y, I guess. And if you can see one that there's something that's all by itself, there isn't a coefficient in front of it like this, that's the one I would solve for. So I'd use that equation and I'd solve for that, y. So, to do that, we're going to take the second equation, we're going to add 2x to both sides. So you end up having y equals 2x minus 3, or plus negative 3. So all this is gone now. So now our new system of equations, our two equations, is 3y plus 4x equals 14, and then y equals 2x minus 3. Step 1, check. 1 is solved for y. Step 2, substitute the expression in for the variable on the other equation. So y is equal to 2x minus 3. That means 2x minus 3 can go in for y. So that would mean step 2 would be 3 instead of y, it's times 2x minus 3. And this is where it can get tricky. It can get confusing sometimes. But y equals 2x minus 3, so y, instead of y, we're going to use 2x minus 3. Everything else is the same in that equation. Step 2 is done. Solve for the remaining variable, which is just x. There's a couple spots there, but we're going to do that. Step 3, let's distribute, because that's what we should do. So first, 6x minus 9 plus 4x equals 14. We have like terms here, so we have 10x minus 9 equals 14. Add 9 to both sides. We're going to try to isolate that x now. 10x equals 25. And finally, divide both sides by 10. Doesn't come out excellent, but we have 2.5 would be our x. Not bad. That is step 3. We solved for that one. Now step 4 says to plug that answer into either equation to solve for the other variable. So let's take that, plug it in for, I don't know, let's just plug it in for this one right here. So step 4, y equals 2 times 2.5, now we're plugging for x, minus 3. So that would be 5, 2 times 2.5 is 5, minus 3, which is 2. So y equals 2. So then our answer, our ordered pair, is 2.5 and 2. Now the last step that we should always do, remember, is to check. So we're going to quick check. Use the original equations. So 3y plus 4x equals 14, and then the other one was negative 2x plus y equals negative 3. Let's plug in here. For y, we're plugging in 2, so it's 3 times 2 plus 4 times the x is 2.5. Is that going to be equal to 14? You can use a calculator to check these, but this would be 6. And this would actually be 10. Uh-oh. Something's not right. Those are not equal. Oh no! So let's look back at our work to see if we made a mistake somewhere. We solved for y correctly here. Plugged in then the 2x minus 3 for the y. Distributed, did this. 2x, so added 9 to both sides. Ah! I can't believe you didn't notice my mistake. Look right here. 14 plus 9 is not 25. It's 23. And then when you divide both sides by 10, it's actually 2.3, not 2.5. So x is equal to 2.3. Alright. So this pays off. This is why we check our answers to see if something is not right. 2.3 is our x. Then we plug that in for that x, and this should actually be 2.3. And I'm going to have to do some erasing now here. So 2.3 times 2 is 4.6 minus 2. So y equals, oh, sorry, minus 3 here, is equal to 1.6. So let's put 1.6 in there. Now let's recheck. See, even I make mistakes. That's why we got to check our work. So let's take those two equations. We had 3y plus 4x equals 14. And we had negative 2x plus y equals negative 3. Alright, let's plug in. 3 times 1.6. Wowzers. Plus 4 times 2.3 should equal 14. So I'll put a little question mark here, if this will cooperate. Oh. And on this side, negative 2 times the x was 2.3 plus 1.6 should equal negative 3. Alright, let's do the left side. 3 times 1.6, that one I just checked is 4.8. 4 times 2.3, I checked also was 9.2. And if you add those together, you get 14. So it works for the first one. Let's check if it works for the second one. Negative 2 times 2.3 would be negative 4.6 plus 1.6. Is that equal to negative 3? And it actually is. Negative 3 equals negative 3. Woohoo! That means our ordered pair actually is decimals, but hey, it was worthwhile to check our answer and get the correct answer. So you look at that, that's a lot of work for one problem. But once you get familiar with those steps, and if you've been following along for chapters to come, a lot of that work shouldn't have taken too long. All right? So that is all we're going to cover for today. If you want to look at the word problem that we'll cover next time, it says a snack bar sells 2 sizes of snack packs. A large snack pack is $5 and a small snack pack is $3. In one day, the snack bar sold 60 snack packs for a total of $220. How many small snack packs did the snack bar sell? So that will conclude our goal right now for solving systems of equations using substitution. We'll do some more examples in the next video and in class.